Example. Here's our world. Let's see if I can make that a bit smaller. There we go. That's good. We got the squid in the way. Or the jelly. Okay, so here's our world. The jelly will be gone in a minute. Now, if you just take a look at our world, and this is one of various maps. I'll show you an example of a different style in just a minute. If you take a look at this world, you'll notice that this world... I'm stalling because the squid is in the way. The jelly... I'm sorry, the jelly's in the way. Jelly, go away! I could probably turn the jelly off. Let me turn the jelly off. Jelly... Pa-pow. Yes. All right, sweet. So here's our world, right? Now, this jumped out to me. I see that there's certain parts of the land here. How do I... There we go. You see that? There's certain parts that seem to go in a circle, and they almost look like the land on Earth is burned in certain areas. And I realized that on this kind of a map, you can see that it goes around and follows the path of the sun. Do you see right here? How the land perfectly is desert all the way around in this little semicircle. I mean, that's the easiest part to see, this right here, right? So let me show what I'm talking about. I'm going to go ahead and fill in the path of our sun. So let me show you our sun, okay? The sun basically goes in a circle like this in the summertime on the northern hemisphere, like this in the southern hemisphere during their summertime, right? And it just goes in circles outward and inward, just like that, okay? Now, let's plot that out. Actually, before we plot that out, let me explain something. And I'm going to get a little bit more advanced for just a moment here, okay? Regardless of your cosmology, okay, I'm asking that you see things and step outside of the box for a moment. See things from this cosmology, from mine. Just for a moment. You can apply it to your own, but it'll make more sense if you just take a leap of faith for just a bit. So basically what happens is the sun spirals around our world. And that's why when it makes a big spiral, it gives us one season, and a tight spiral gives us another season. That has to do with the plasma that exists above our world that feeds light into our world and gives us a focal point of what we call the sun or sunlight or daytime. Okay? Now, above us, that plasma that's shooting down over our world is pulsating. Okay? It goes wide, whoosh, it's got its maximum, and then it tightens up. And when it tightens up, it spins, right? It's always spinning. Everything spins. It's always spinning in like a circle or a vortex, okay? So basically, whenever we have one plasma apocalypse, that's when the plasma above goes way too far out, okay? It goes into flux. It goes so far out, and then it goes everywhere. We hit our neutral point. Okay, and because the plasma goes so far out, that means that the light that's refracted through the sky and coming down into our world cannot make a focal point. It hits the ground where the focal point should be. So that means there is no sun. The sun disappears. That's around winter time, around Christmas and New Year's, basically. And we have a lot of traditions that are built around that time so that people will light candles and make sure and ensure that they have light during the time of darkness. However, there is another plasma apocalypse that happens that is the inverse. One brings water and a flooding, as you can see. You can kind of tell which one we last went through, okay? That water in our world, everybody looks at that and does not think twice, which blows my mind. They say that's just the ocean. No. That's the flood. Okay, I just want to be very clear. That is the evidence of the worldwide flooding that has happened. Okay, we should have way more land than that. That's way too much water. Anyways, the other one happens around the 4th of July in summertime. You know, somewhere around there. Summer solstice, basically. And what happens is that instead of the plasma going so wide that it goes into flux, it gets super tight, and it gets super tight before it goes into flux. Okay, it's the opposite. Now, when that plasma above gets super tight, that sunlight also gets super tight. And what that means for our sun is it gets brighter and hotter. Way hotter. Starts setting things on fire. Now, I show you this picture because, as you can see, if we trace the path of the sun as it transcends that boundary where it's supposed to stop during the northern hemisphere summertime and it continues to spiral in towards the North Pole, let's see what that looks like. Boom. Now, this is just a rough drawing, okay? But as you can see, the sun going east to west whoosh, makes a spiral, and all these places where it touches, you'll notice Why isn't it going back? Is it... How do you make it go back? Oh, see? There we go. Okay. You'll notice, sorry, you'll notice that they're all brown. They're all burned. Look at these burn marks all over the place from here all the way to the tip. Now look at Africa, okay? For some reason, the tip here is all burnt. The middle is all lush with greenery. And then this entire semicircle on the inside is all burnt as well. And then just on the other side of that, we've got lush green. All the areas in between are basically lush and green. Do you see that? Okay, so that to me is, supportive evidence that the sun bakes the earth in these places as it spirals inward, and the light is intensified, essentially like a laser. So now, let me go ahead and show you a different map, because I promised I would. Booyah, here's a different map right here. Let's see, let me make this a bit bigger so we can all see here. That's not bad, right? So here's another map, okay? This one, as you can tell, you see Australia, South Africa, the tip down here, and then all across the top. Let's go ahead and put in our lines. Pow. There's one. Pow. There's another one. You see, it's the same exact thing. The sun leaves burn marks on the land as it goes. Now, this isn't day to day. This isn't today it's doing this, okay? The sun has to be very hot. The heat that comes down, that daylight, has to be super hot. So let me go ahead and take that off there so you can just see it again. All right, so this is something that I made. Do I have any other pictures to share? Let's see. Not so much. But you can look this up for yourself, and you can clearly see where the sun has scorched the earth on its path. Now, where does it go? I want to show you that real quick. Where does the sun go? So let's bring it back up. The sun goes to the middle. Okay, so it spirals inwards, and this is during the summer solstice. Okay, it spirals inward. And the light is so focused because that plasma on the outside of our world, or if you're an academic, the plasmasphere, okay, if you want to call it that, that light that's coming down from the plasma, keep in mind the plasma is repelled by, if you want to call it our atmosphere, I would say it's a physical dome of sky, but it's repelled by that. So the plasma, the physical plasma goes around, the light passes through what I believe to be perfectly clear ice above us. And to get more detail on how the sky possibly has a dome that's made of ice, you'll have to check out some of my other videos because that's way too lengthy for me to get into now.